Welcome everybody to our third Virtual Ethical Innovation Lecture, or VAIL as we call it. This time we're welcoming Ansgar Koene. And before I'll introduce him briefly, I just want to say a few words of our intentions behind this kind of lecture series, because we actually are a small research group that is intent on connecting technologists and humanities, social sciences. So giving some room for us to engage with each other. And in that respect, we intend to help disseminate some insights or spread the word about interesting initiatives or spark a debate about the ethical and societal aspects of technology in general. And we are particularly happy that you were all able to fit this lecture into your probably quite rather busy schedule. So in fact, we've actually designed this format such that any interested person that does not read about ethics of technology every day can have a bite-sized introduction to several of the important aspects, meet interesting minds on the way, and maybe something comes from it that goes further along here. I would also like to express my gratitude because the VAILs are also supported by the Academy of Humanities and Sciences in Hamburg. A quick word about us as a research group. We are the Ethical Innovation Hub, as we call ourselves, and we are a research group that is a joint venture of both the Institute for Electrical Engineering and Medicine and the Institute for the History of Medicine and Science Studies at the University of Lübeck. In this regard, we are also building bridges here locally. But essentially what we want to do is we want to do research on how ethical considerations can be used as a kind of driver for innovation and technology and development processes, and how to integrate these ethical considerations there in a practically sound way. We had a number of VAILs in the past, one by Wolf Loh. He talked about translating principles to practice. We also saw a participatory approach for an app design by the Swiss Federal Railways. And today we have Ansgar Koene talking about principles, standards, and regulation for trustworthy AI. For this term, so we're sticking to the German semesters here, we'll also have Thomas Losse-Müller talking about sustainability considerations for the digital transformation. But before we get that, of course, we want to get to today's talk. And I think everybody of you probably has already noticed that there's been a lot of talk about one particular ethical implication that could arise from what is often termed algorithmic bias. So basically the tendency of any algorithm to favor certain decisions or people or aspects in an unfair way. Usually that's implied in this sense. And I think in this field, you would be hard pressed not to have come across today's speaker, because he's not only published in that regard, but he's also the chair of the IEEE P7003 standard on algorithmic bias considerations, as well as being a senior researcher at the University of Nottingham and the global AI ethics and regulatory leader at EY. And today, as I already said, Ansgar Koene will talk about principles, standards, and regulation for trustworthy AI. In our brief discussion leading up to the Virtual Ethical Innovation lecture, I asked Ansgar to shed some light on the tensions that arise, or do not arise for that matter, if that is any, at some point maybe even also the case, when business self-regulation, government regulation, and academic perspectives, or maybe societal perspectives even, on what should be guiding ethical principles clash. And I think he's profoundly capable and has the right affiliations to actually be talking about this from a first-hand perspective. So I'm very much looking forward to your insights here. So before we start, there's this Q&A section. I'd be happy if you could just type in your questions also as the presentation goes along. We'll be having the option to discuss this also using the microphone, but let's please first give Ansgar the possibility to go through his presentation in its entirety, and afterwards we'll moderate the questions. So with this, without further ado, I'd like Ansgar to share his slides and continue with his presentation.
Self-Regulation for Trustworthy AI. And really what I want to do is talk a little bit about how these things interact with each other, the relative roles of principles, of standards, and of regulation with each other, and also sort of how some of them cover certain domains and others cover other parts of how we want to make sure that there is a good ecosystem of trust, as the European Union likes to call it nowadays, around AI. So just to start off, a quick reflection on the Gartner hype cycle. This is something that industry always likes to look at, and this is from 2019. And really what I just wanted to point out on this hype cycle around artificial intelligence is sort of the relative positions within this, where you can find certain types of leading AI technologies like computer vision, which is already sort of in 2019 was on the drop there. Then digital ethics, following that, sort of in 2019 reaching sort of their estimate of the peak of hype, but AI governance actually following quite a bit further behind. So there's a bit of a disconnect between the discussion around digital ethics and the actual sort of formulating that into governance procedures. And so obviously you will all have heard of the various AI principles that have proliferated, especially sort of around about 2018 and 2019. The Berkman Klein Institute made a beautiful visualization of trying to capture what a lot of these are focusing on and trying to compare where their particular focus is. But there have been many others from academia, such as the Asilomar AI principles, but also from industry, for instance, Microsoft AI principles, from technical societies like IEEE, the European Commission's high-level expert group, and the OECD's principles are the ones that I'm going to want to focus on a little bit more, because these have sort of become a reference point for a lot of the discussions in the policy space, because really what the OECD, with their network of experts on AI and their observatory on AI policy, is hoping to do is to try and make sure that the various different AI governances in the different countries within the OECD and hopefully even beyond that is somewhat coherent with each other. We don't get dramatic differences between the way in which Europe or the US or say Japan is organizing their AI governance. And so the core principles that the OECD has described, and which you will find more or less in copied or mirrored in other AI principles, are around ensuring well-being, that AI is, it's the beneficence principle, human-centered values, so the fact that humans should be at the center of the use of AI, transparency and explainability, robustness, security and safety, and accountability. An interesting paper that was published more recently by Kansu Kanka, I think was her name, did a very nice sort of assessment, or sort of separating these principles a little bit as to what are fundamental values that are intrinsically things that humans are interested in, which is things like the beneficence one, the top one, and human-centered values and fairness, and the other principles which are more instrumental in that they are important, but their importance comes from how they serve to achieve the intrinsic ones. So transparency in itself isn't really what you're interested in. You're interested in transparency because transparency helps you know whether the system is potentially causing harm. And the same for robustness questions and accountability. So the problem with principles is that they are very important and interesting from a point of view of laying out what you want at sort of a high level, but they don't define how to get there. They don't give you something specific that you can test against, where you can say, does this particular AI application comply, yes or no? And so there's been, the kind of typical critiques of AI principles around how will you actually measure well-being? What does human-centered actually mean, especially if we're thinking about the various different kinds of contexts of AI? How much transparency is enough, and what kind of explanation do you need for different kinds of stakeholders? All those kinds of questions. What kind of robustness relative to what type of perturbations? The principle of robustness doesn't specify this. And where should accountability lie? If you say there needs to be accountability, but who should hold this? How does this exactly relate to things like legal liability? Those kinds of issues come to the fore. But why is there even this kind of a discussion happening? On the one hand, obviously, we are pushing to try and use AI because of its potential to help society. For instance, these are just some of the ways in which computer vision can be useful to society. There's a project at the University of Nottingham, for instance, around using computer vision on satellite imagery to identify modern-day slavery, or catching criminals is one of the examples used frequently in China, for instance. Why do you want to use face recognition all over the place? Finding missing persons. So there are all kinds of ways in which computer vision can lead to beneficial outcomes. However, at the same time, we are well aware that there are problems with this kind of technology if it is implemented without clear boundaries, without sufficient understanding around this technology. Staying in the realm of computer vision just for now, and for instance, face recognition, there's obviously the issues with the use of that in policing. On the one hand, error rates can be quite high, and the question is, how are these errors being treated? And that is often not really known clear on the outside. There's a lack of communication between the police and other stakeholders around this. And this has led to things like bans on the use of face recognition in policing use in various states in the US. And this is one element that I'd like to reflect on when it comes to things like regulation, is that regulation really comes in two kinds of flavors. You have regulatory responses that are really reactive, which is what we've seen primarily in things like face recognition, but also increasingly in things like the use of AI in hiring, is that it was rolled out at a wide scale, and then there was a public response to this, a public outcry of abuse of this technology, which led to strong regulatory response, such as basically banning the use outright completely for these particular applications. The other way of doing regulation is the more structural principle kind of approach, which is what we, for instance, see in the European Union through the process of having a high-level expert group, then leading to proposals and a white paper, etc., which is a slower process. It has the potential to generate better regulation, but it is something that can at times feel like it's taking too long to get there. And really what you're seeing is the two different sides, and industry is sort of within this space needing to make sure that it doesn't trigger ad hoc regulatory responses that aren't sufficiently fine-tuned, but it supports proper good regulation that will actually build trust in these kinds of technologies. And so this is what I already mentioned, the various legal bans on face recognition that were a response of bad use of this technology. AI is at the top of the agenda for many governments around, specifically in developed nations, but also increasingly in developing nations, such as India, for instance. There is increased attention to the question about how to regulate AI because it is being seen as a potential motor for increasing the economy and potential motor for increasing the ability of public sector to provide services. And the EU specifically is trying to be a leader in this kind of race to regulate, building on its sort of success with GDPR in promoting privacy regulation globally. The European Union has been building on this for a while. In 2016 already there were parliamentary discussions. In 2018 the high-level expert group and various reports were requested from the European Parliament's research services, for instance. 2020 we had the white paper, which laid out really how the European Commission is translating the outcomes from the high-level expert group into potential policy directions, so the ecosystem of trust and the ecosystem of excellence. This went through a consultation process that received a huge number of responses, and the European Commission is expected to come back with their assessment outcomes of these responses pretty soon. Both the civil society and the industry contributed heavily to these responses. And we have already heard, for instance, from Commissioner Verstaegen that they will probably be changing, for instance, the way in which assessments are being done as to what is a high-risk kind of AI, based on the way the feedback that was received. So the original method was around identifying certain sectors and then within that sector looking a bit more specifically at the properties of that application. But really now the idea is to move away from the sector-specific one and more to the properties of the AI system as being the driver of whether it's high risk or not, more or less irrespective of the sector, though that will still be one component within the assessment. But we are waiting to hear more clarity about the methodology that they're proposing now. So what I wanted to reflect on now is a bit sort of different kinds of governance frameworks that can be used, generally speaking, around technology, and then also, of course, applying to AI. And roughly speaking, so this was a very nice assessment by Florian Sauerwein and co-authors. You can sort of segment this into a number of categories: the market solutions, demand side and supply side. So this is sort of the free market idea of whatever product has the best properties is going to be most valued by consumers, and that the consumer response will really drive the technology to become better. There are limitations to where this can actually work. And so therefore, there are other kinds of governance that are necessary. Things like company self-regulation, either at the individual company or at a branch level. Then there's co-regulation, which is a coordination between government setting the need for regulation and industry providing the details around it. Standards generally fall into that kind of space. And state intervention, which is when the state makes a strong intervention and says these things are not allowed, or in order to be able to put your product on the market, it has to have these and these requirements. So GDPR falls under state intervention, for instance. So market solutions, as I said, two different kinds of methodologies there, but we've seen in the digital sector that there are problems with trying to use the market as a way of doing regulation. Typically, one of the problems is the network effects and the concentration of markets. In the AI space, we can think of the need for cloud computing facilities, and there's only a small handful of providers of this. The increasing size of the AI models and the difficulties of training these, which makes concentration of market power, which makes it difficult for anybody to choose an alternative to a particular solution. And that really limits the potential for demand side kind of shifts. The example being here was around social media, actually, and advertising networks that only really big companies that are pushing for certain types of changes because of their market potential, the amount of money that they invest in it, have a potential to make a change there. Supply side solutions is really the idea that new options are being put onto the market, and that new companies spot a gap in the market, like offering methodologies for assessing the trustworthiness of your AI, such as the robustness, or doing assessments around bias in the outcomes. EY is one of those that is trying to build out market offerings in this space. IBM also has some, as do various other companies. However, there is, the actual uptake of these is linked to the existence or the threat of state intervention types of responses, and I'll talk about that a bit later. At the self-regulation side, we have things company level, and there, the most interesting that we've seen is actually that a lot of the company level kind of self-regulation has been less from the top down, through the company organization, and more from the bottom up through workers within the technology workers. So we've seen that, for instance, in the big tech sectors, like tech companies like Google and Apple and Amazon, where it was the employees that made a big statement around refusing to work on certain projects, which is what caused these companies to shift certain of their activities. It wasn't really so much the top-level management that had been taking leadership on it. Branch level kind of self-regulation, this generally takes the form of standards. So this is really the experts coming together, and mostly these are experts from industry, even though the process is open for participation by academia and civil society. The way in which it operates tends to be somewhat difficult for NGOs to participate in, just because of the time and also the money for traveling to events. So that's less the case at this moment. It is needed. But so the main focus at the moment around AI is that most of the national standards bodies, DIN, for instance, in Germany, are participating at and pooling their activities at the international level, at the ISO. So ISO IEC has a major standards working group, the JTC1 SC42, that has a number of activities going on to develop standards, really definitions of best practice around the use of AI technologies, including a standard on governance of AI, a standard on robustness of neural networks, a standard, or rather at this moment, a technical report on the societal impacts of AI. So there's quite a number of activities happening there. But standards also take generally 3 to 5 years to reach development, and this general activity started in 2018. So most of these we are expecting to come out in the next year or two. IEEE similarly has been working on standards, and I'll talk a bit more about some of that work. The slight difference between the ISO and the IEEE work is that IEEE has made a particular decision to say they're going to set up a series of standards focused on ethical issues of AI, whereas much of the work that ISO is doing is more focused on technical dimensions around this. There's also other standards bodies. Sensenelec, for instance, is a European one. Again, there's cooperation between these and the ISO one. Sensenelec effectively is asking, are there certain elements to the way in which AI should be done in Europe that would be different from the international one, and therefore that would require a European-specific standard. And so at state intervention, there we've seen things like co-regulation, which was, for instance, the privacy shield in the data space, which was basically government saying you need to have these GDPR-compliant privacy measures, but under the privacy shield, US companies would be able to self-assess themselves against these. This famously has been destroyed by the Schrems II ruling, and Europe and the US are currently trying to figure out an alternative because this kind of self-assessment was found to be insufficient, and US law was found to be too problematic because of its ability to give access to personal data to things like national security agencies. At the hard legislative action, we've seen things like in France, the digital bill, which demands that any use of algorithmic systems in the public sector has to be explainable, and that has had implications on the type of AI systems that could be used, and the aforementioned sort of actions around blocking the use of face recognition, for instance, in various states is a legislative action kind of examples. So a little bit more about what the IEEE has been doing and sort of a little bit more examples of how standards operate and what their role is. So the IEEE launched its Global Initiative on Ethics of Autonomous Intelligent Systems in end of 2016. And along with it, really, it launched two major branches. One was the ethically aligned design, effectively outlining further sort of principles and going a bit more deeply into a discussion around principles, but the other being this series of P7000 series of standards, which is standards focusing on ethical dimensions of AI. So the initial set being the ones around how to introduce ethical concerns during system design, the P7000 one, 7001 transparency, 7002 data privacy, 7003 bias considerations. And then beyond that became more specific, for instance, things such as fail-safe design, also very important, and a benchmarking of face recognition, for instance. So if we take a look at, for instance, the sort of the core thinking behind this is that algorithmic systems are socio-technical. They are not just a technical system, but really they're about, what you need to be thinking about is the way in which the system is being used within organizations. It's being built by people within organizations, which is people really, within a society that has political and legal and cultural context, which is things that are shaped by people. So really, people are at the heart of the way in which the technology is being developed and also the way in which impacts of this are being sensed. And so therefore, any kind of serious thinking about the way in which technology, what is best practice for the technology needs to be reflecting on this human social aspect as well as the technology one. So the 7003 algorithmic bias considerations one is really looking to address these questions about bias and the associated fairness questions. But to start with, we have to recognize that it is bias considerations, not removal of bias, because any system that makes an actual decision that isn't just a random uniform distribution of outcomes is going to be biased from a certain point of view. And really what you want to make sure is that you're avoiding unintended or unjustified or unacceptable kinds of bias within the context of use. It's really be clear about what it is that you're trying to achieve with this and why it is that the way in which the decisions are being made is appropriate for that kind of a use case. Causes of algorithmic bias, generally speaking, can be identified as being insufficient understanding of the context of use, including what kind of people are going to be impacted by it, failure to rigorously map the decision criteria, such as why is it that we're actually optimizing for this and not for that, failure to explicitly justify those chosen criteria and communicate those justifications to the relevant stakeholders. So typical examples of that being bias due to the data. There's been a lot of focus on this, historical data being biased because of the imperfections in our society, and so training a system based on historical data will replicate that kind of bias and potentially make it even more difficult to remove that bias because it has now become built into an automated system. Another problem, however, which has been attracting less attention but is at least as important, is a question about how are optimization targets being identified. And this was, for instance, the case in the COMPASS system, the system for identifying whether or not somebody should be up for early parole or not, based on a questionnaire that the arrested person had to fill in, and that questionnaire, which covered 100 and something questions related to their life, was trying to assess whether they're likely to be reoffenders. And the problem there was the way in which to optimize the system's performance. The developers of the system had made it to be optimized for generating equal accuracy for both black and white defendants. However, assessment of the performance of the system by the journalists of ProPublica was focusing on what kind of errors does the system make when it does make an error. So what do the false positives and the false negatives look like? And it showed that there were severe racial disparities within that, with black defendants typically, when the system makes an error, being falsely assumed to be more likely to reoffend, and white defendants being assumed to be more likely or less likely to reoffend. So really what this highlighted is the problem with how to choose optimization, because typically you cannot build systems to be unbiased along all different kinds of dimensions. At the same time, accuracy, false positives, and false negatives cannot all be made unbiased because of the inherent nature of the data sets. And so there needs to be a discussion as to what is the appropriate way of choosing how to select your optimization criteria, and that needs to be an open process. It needs to be something that is communicated, and there needs to be an ability by society to have an input in this. It cannot be something that an industry simply does on itself. And third dimension, and just today I was seeing this coming back into the news, is the problem of effectively reducing complex individuals into simplistic stereotypes. And so, which was very much highlighted by that paper on the machine gaydar, trying to identify people's sexual orientation based on their faces. And the algorithm, the way the algorithm was being built, even from the start, just put in the assumption that sexuality is a binary, which is not the case. And so therefore, it has already reduced the complexity of humans to a very much simplified kind of world. And that is one of the things where a lot of concerns really come from. For instance, if you talk to people, transsexuals or such, for instance, they will say they don't really care whether or not the algorithm is capable of indicating that they are of this gender or of that gender. What they care is that a assessment about them is being done without asking them about it, that they're not part of the conversation. And so really that is one of the bigger questions around the use of AI is, are we trying to automate away too much of human engagement and human agency in these processes? So questions that we put forward within the algorithmic bias considerations standard is really to focus the developers on making sure that they are aware of who will be affected by the system, what the decision optimization criteria are that they're using, how these are being justified, and whether these are acceptable within the context of system use, and really being clear as to defining what is the context for which this has been built and assessed, and clear that you cannot simply transfer to different contexts without having to do a reassessment around these. The IEEE is also working on things like certification, and there's more work happening also outside of the IEEE around certification of AI systems. However, there's still some question marks about what exactly it is that should be certified. Is it the people developing these systems? Is it the particular application? Is it the organization? All of these in what kind of way. For instance, when the European Commission's AI white paper talks about voluntary labeling of systems as one of the things to do for non-high risk AI, what kind of labeling are they talking about, and what is it really that should be self-certified in that kind of case in order to provide useful trust indicators to users? So in the ECBI project, which was the ethics certification project for AI at IEEE, the initial work focused on three main things: certification around transparency, accountability, and algorithmic bias. And those have been developed, and now the IEEE is in the process of identifying how best really to operationalize these certification ideas, these programs, into use. How would industry be motivated to pick them up, and how should they be communicated to users? I won't go into this kind of detail. And that brings me to the end of the presentation, and I'd like to open up for Q&A now. Thank you.
Well, thank you very much for this interesting and broad and detailed overview.